In an earlier video, we discussed the dismantling and overhaul of a simple single-stage foot pump, such as shown here. That's a foot pump with one piston in one barrel. This type of foot pump was widely manufactured and distributed, but in 1926, William Turner of Sheffield, the Kismet Company, took out a patent for the so-called improved single-stage design of foot pump, sometimes called the enhanced single-stage, and this is an example of this enhanced single-stage foot pump, which has a design modification to improve the efficiency and performance of a single-stage pump. When the patent expired, many firms took up this new idea, and a whole variety of enhanced or improved single-stage foot pumps were produced, and we'll talk about some of those in a moment. But the purpose of this video is to go into detail about the enhancement or the improvement that Turner developed for single-stage pumps, and to discuss the dismantling, overhaul and maintenance of these pumps. Here we have a few examples of enhanced or improved single-stage foot pumps, which illustrate just how widespread the principle became and how many manufacturers adopted this principle after the initial patent. So first of all, here we have the Kismet lorry, which was the first pump produced under this improved or enhanced method, followed by Kismet's sequel pump, but also Dunlop took on the idea and produced the Dunlop Major, and also the Dunlop Standard foot pump is of a similar enhanced or improved single-stage design. PCL in their Emperor Mark I pump used the principle as well, and in this pump, which is branded Dunlop but was actually made by PCL for Dunlop at this point, and it's identical to the PCL Emperor Mark II pump. And here finally we have the Romac heavy duty pump, which again is based on this enhanced or improved single stage principle. So it became a very widely adopted approach for designing improved pumps, and now we'll get into some of the details and explain the working principles of this design and the hints and tips for overhaul and maintenance. To explain the workings of the enhanced single-stage design pump, it's best to look directly at one of the drawings from the original patent. Patent is number 249997, dated April 1926. Improvements in or relating to foot-operated pumps for inflating tyres and the likes, by William Turner. The first thing to note is that the pencil points to a non-return valve. This is located in the piston head, and then on the working stroke, the downstroke, air is compressed in front of that piston and passes through the non-return valve into a large hollow piston rod, which is designated here with the letter F. On the real pump here, the Dunlop Major, one can see the non-return valve located in the centre of the piston head and the leather washer. When the air passes into this large hollow piston rod, it exits via a tiny exit aperture at the front of the pump into the tyre. Now, because this hollow piston rod is pumped up sequentially in each working or downstroke, the pressure in that piston rod increases, and air is delivered into the tyre at a rate determined by the pressure differential and the flow characteristics in that very thin transfer conduit at the front. What this means in practice is that air exits that hollow piston rod and enters the tyre continuously during the working downstroke and the upstroke. And this is the major benefit of this pump, that air is delivered both on the downstroke and the upstroke and is continuously therefore transferred to the tyre. The consecutive downstrokes then continually reinforce the pressure in this reservoir, this hollow reservoir, and continually therefore arranges for air to be delivered to the tyre. If one wants to make an analogy, this is rather similar to the principle of bagpipes, where the player of the bagpipes blows continuously into the air sac, which then delivers air through the drones, the items that make the sound in the bagpipe. But the pressure or the blowing continues during playing, and playing can continue when the bagpipe player has stopped blowing for a certain time. So that's the basic principle of the enhanced single stage pump, and we'll now talk about some of the details of dismantling it and cleaning it and overhauling it to make sure it works optimally. In order to examine the details and discuss the overhaul and maintenance of an enhanced single stage pump, I've taken off the piston head arrangement and dismantled it to show the non-return valve, and also taken the cup washer off so one can see how it all comes apart. The piston head is shown here with its hollow inside and a seating where a ball bearing can sit in there to block the flow. The ball bearing is 1/4 inch diameter, 6.33 millimeters. This is a new one that's been inserted in this pump. A small soft spring to keep the ball bearing in place, which fits into this brass housing, which screws into the back of the piston head, keeping the ball bearing in place to do its job to prevent backflow from the tyre. So a very simple arrangement. The most important thing from a maintenance viewpoint, to clean out that seating for the ball bearing, make sure the ball bearing is not pitted or damaged in any way, and to ensure the spring is a soft spring such that it just keeps the ball bearing in place. The leather cup washer you see here has been made using a standard former based on the diameter of the barrel. Interestingly, in virtually all of these enhanced single stage foot pumps, the cup washer and the diameter of the barrel are exactly the same. So a cup washer from one is transferable and can easily be fitted into another. As usual, the oiling of this cup washer with neat's foot or vegetable oil, not mineral oil, is necessary, together with cleaning out of the barrel and oiling the pressure surfaces in that barrel. So those are the basic components of the pump which cause pressure to be raised in front of the piston and passed successively during every working stroke into the thin hollow piston rod, which forms a high pressure reservoir, as you can see here. And looking into this high pressure reservoir, one can just see the tiny outlet hole at the far end which connects the reservoir to the tyre. So overall, a simple, straightforward design to fulfill the purpose of the enhanced single stage operation. Finally, a couple of details to bear in mind when overhauling and servicing an enhanced single stage foot pump. First of all, in this example, the Dunlop Major, we see that the return spring is of a coiled tension type. This means that the coil spring is held on spiral grooves and goes into tension on the downstroke. When it returns to its original length, as shown here, it returns the foot pedal to the top. So quite an unusual design, a tension coiled spring which you find on the Dunlop Major and on the Dunlop Standard. But by far the majority of these enhanced single stage foot pumps employed an external compression spring going around the high pressure reservoir you see here on the outside of the pump in front of the barrel. So those are the most common designs you find. I can provide these coiled tension springs and also the external compression springs if you need to replace them during servicing. Finally, looking at the outlet of the pump, one sees the orifice at the bottom which connects to the flexible hose and the tyre, but at the top is a pressure test valve, a simple arrangement with an internal Schrader valve in there, so pressure can be taken with a small handheld gauge without disconnecting. Not all of the enhanced single stage foot pumps have this, but several of them do. If one's servicing the pump, of course, taking out that Schrader valve with a small tool, cleaning it, putting it back, checking that it doesn't leak, and if necessary replacing the Schrader valve core is the thing to do. These can be obtained from any tyre accessory shop, and they will probably fit it for you if you request it. So there we have the enhanced single stage foot pump. This is the Dunlop Major example with the coiled internal tension spring, but many other examples are similar but have the external compression spring to return the foot pedal. We've now covered most of the main points concerning the workings and overhaul of enhanced single stage foot pumps. They come in a variety of types. Some have pressure test valves at the front, others don't. Some have internal tension springs, others have external compression springs. So there are differences between them, but the two common features which allow you to recognise an enhanced single stage pump are the hollow piston barrel operating as a high pressure reservoir, which you see here and here and here, and the fact that the air outlets on these pumps are always at the front end of that high pressure reservoir. So those features will normally allow you to identify whether you have an enhanced single stage pump, but just to confuse you, Kismet did produce a pump called the Kismet Junior, which also has a very thick piston rod, but this is not hollow, so this is not an enhanced single stage pump, although it resembles it in terms of having this large thick piston rod. The fact that the air outlet is at the back on this pump confirms the fact that it's just a regular single stage pump. So with that exception in mind, don't be confused. Any pump you see with a thick hollow piston rod is likely, almost certain, to be an enhanced single stage pump, and with the advantages that come with that sort of design.